All right, so now we're going to talk about glands. We just finished with epithelial tissue. I'd like to talk about glands now because glands are mainly composed of epithelium. There is connective tissue, of course, associated with glands because anywhere we have epithelial tissue, we always have to have a basement membrane of areolar connective tissue. So glandular tissue is tissue that secretes some type of materials. There are exocrine glands, and then there are endocrine glands. Exocrine glands secrete things like mucins or electrolytes or enzymes or urea, whereas endocrine glands secrete hormones. In this semester, we don't tend to focus on endocrine glands. Next semester, we will. So, something you do want to know now, but that we'll talk a lot about in chapter 17, endocrine glands are ductless glands. So they have to have a means to pass their chemicals, which are hormones, into the blood. So when they secrete chemicals, they secrete them right into the blood. And then the blood circulates these chemicals, which are hormones, to the proper cells of the body, and then, different reactions occur. We'll focus on exocrine glands here, though. So exocrine glands are glands that secrete to the surface of, or to some lumen, I won't say the surface of, to a lumen. The exocrine glands that we mainly talk about, sweat glands, which are known as sudoriferous glands, mammary glands, ceremonious glands. Ceremonious glands I don't have listed there, but those are wax-producing glands, and mammary glands are actually modified glands. Salivary glands, these are glands that secrete salivary enzymes, so saliva and enzymes. And then sebaceous glands, which are oil-producing glands. This is what an exocrine gland looks like. This is an exocrine gland. Here is one of the ducts of an exocrine gland. So they produce and secrete chemicals. Those chemicals go to the lumen, and then that lumen leads to some opening, either, like this, a pore on the skin or something like that, okay? So we have different types of exocrine glands. We have merocrine glands. Merocrine glands use the process of exocytosis to package their secretions. This is how we get sweat to the surface of our body. Saliva, lacrimal glands, which are tear-producing glands, the gastric glands of our stomach, all are merocrine glands. So if it's a merocrine sweat gland, it's a merocrine sudoriferous gland. Fun, right? And then we have apocrine glands. Apocrine glands are glands that pinch off. So it's similar to the producing a vesicle through exocytosis, but in this case, we just pinch off a piece of the apical membrane, and secretory or secretions are found in that little tiny piece. Okay, so it's almost like do you remember pinocytosis and endocytosis? Endocytosis producing a vesicle and pulling things in, large things. Pinocytosis is tiny little droplets. It's kind of like that, except for in reverse. So it's an exocytosis process, but we're just pinching off a tiny portion of the apical membrane. So we have sweat glands, again, that are apocrine sweat glands or apocrine sudoriferous glands. These are the sweat glands that get activated at puberty and start producing sweat in both the pubic and axillary regions. These are also the sweat glands that produce the stress sweat, so that smelly sweat that people talk about. Our mammary glands are also apocrine glands. Holocrine glands then are glands that in which the cells of the exocrine gland just basically become the secretion. They break down and new cells form. And so this is how sebaceous glands work. So oil-producing glands in our skin work. These are holocrine glands. So here is your typical endocytosis or exocytosis, where you're producing vesicles and we're releasing materials. Or I'm sorry, with exocytosis, the chemicals are being released straight out. Here we're blubbing off materials from the apical surface, producing tiny little vesicles that are being released. This is your stress sweat, your regular sweat, breast milk, salivary glands. And then this is the holocrine sebaceous glands, an example, okay? The next tissue we'll talk about then is connective tissue. Connective tissue is the most common tissue in the body. It makes up the majority of all of our body parts. It is mainly functions in support, in protection, in binding things together. It stores things, it has other functions as well, like storage or delivering nutrients. So it has a lot of different functions, but some of the major things are support, protection, and binding. Connective tissue also has a lot of cells, a lot of different cell types, whereas epithelial tissue, mainly it's composed of epithelial cells. Connective tissue has lots of different cell types, and the cell types produce a lot of proteins and the proteins are surrounded in a ground substance, and the proteins and the ground substance together make up what we call an extracellular matrix. So we have living cells, and then we have non-living matrix that surrounds connective tissue. Let's look at the different cell types. So each connective tissue type has different types of cells. So adipose connective tissue has cells called adipocytes, but adipocytes might be found in other connective tissues as well. Cartilage connective tissues have chondrocytes. Bone connective tissue has osteocytes. And in general, the cells are not in contact with each other. Cells are not packed in like they are with epithelial tissue. In connective tissue, the cells are very loosely, or no, I won't say loosely packed. I'll say they're found in the matrix, but they don't typically touch. We have some cells that are called resident cells that are always found in the connective tissue. And then we have other cells that are wandering cells that move in and out depending on what is needed. So examples of resident cells. Fibroblasts are resident cells that produce protein fibers. They also produce a lot of the ground substance associated with the extracellular matrix. Adipocytes, which are fat cells, are connective tissue cells that are found in adipose connective tissue, as well as a lot of other connective tissues. Mesenchymal cells are your embryonic stem cells that make all of your connective tissues. So these are the stem cells that will divide and produce new connective tissue cells when needed. We have fixed macrophages. These are white blood cells that sit in the extracellular matrix, and they basically just stay there and wait for pathogens or damaged cells to come along, and then they get rid of them. They phagocytize. Mast cells are tiny cells that, when they get activated, secrete heparin, which inhibits blood clotting and increases and histamine, which increases the flow of blood. So heparin kind of makes blood move, it makes it thinner so that you don't have blood clotting. And then histamine dilates blood vessels, causing blood to be able to flow even faster. So it increases inflammation. Plasma cells are B lymphocytes that are activated, and they produce antibodies continuously when they are activated. Then we have wandering cells. Wandering cells are cells that move through our connective tissue, and when something happens, typically an invasion of some pathogen, then the wandering macrophages or the other wandering cells like neutrophils or lymphocytes or eosinophils come along, and they will get rid of the pathogen so that we are safe. So we have these fibroblasts, and their job is to produce fibers that are found in connective tissue. There are different fiber types, and each of the fiber types has different functions. So collagen fibers, very important to connective tissue. These are flexible yet very strong protein fibers that protect different organs. We'll find them in ligaments and tendons, in bone. Reticular fibers, these are thinner than collagen fibers, and their job is to give more of a framework to different structures. So most of our lymphatic tissues have a very nice reticular connective tissue stroma, and allows the structure of that organ to be maintained at all times. And then we have elastic fibers. Elastic fibers are fibers that stretch and recoil very easily. So organs can maintain shape. Think of your ear. Your ear can bend and it flips right back to shape. Your lungs can expand and then go right back to normal. The ground substance then is material made by many of your connective tissue cells, like your fibroblasts, and it functions the ground substance plus the protein fibers function as the extracellular matrix. This extracellular matrix can be liquid, semi-solid, or solid, depending on the number of fibers and the amount of proteins associated with it. So, example, blood is connective tissue that is liquid or viscous. The ground substance is viscous. Cartilage has a semi-solid ground substance, and then bone has a solid ground substance. The ground substance is composed of glycosaminoglycans or proteoglycans and glycoproteins. These help to bind the cells and the proteins together and forms the connective tissue. So here's a nice picture showing the extracellular matrix with all the different cell types you might have. So let's talk about the basic functions of connective tissues then. One major function of connective tissue is protection. A lot of our connective tissues function in protection. So blood has white blood cells that protect us. Bone protects the underlying soft organs. Adipose connective tissue surrounds our organs and gives kind of a cushion to those organs. So a lot of our connective tissues are protective in nature. Support, so bone provides the framework for the body, so it is definitely supportive. Cartilage provides framework as well, so our nasal cavity, we have cartilage in it. Our ear is cartilage, and the fetal skeleton is composed of cartilage, predominantly cartilage initially. So it gives a lot of support. Binding, ligaments and tendons bind either bone to bone or muscles to bone. We have dense irregular connective tissue that binds our skin to our muscles and our bones that are deeper. And then we have storage. Storage, bone stores calcium and phosphate. Bone also stores excess adipose tissue. Adipose tissue stores excess energy. I mean, there's a lot of functions of connective tissues. Transport, blood is connective tissue and it transports nutrients and waste products throughout the body. And then blood also provides immune protection. Our lymphocytes are specific defenders against diseases, which we'll talk about next semester as well. And we're going to talk quickly about the initial connective tissue, the primary connective tissue that gives rise to all other connective tissues. This is called mesenchymal connective tissue. So this is connective tissue that develops initially in the embryo, and it's found in all of our connective tissues and basically produces new connective tissue cells when we need them. So it's the stem cell to all connective tissues. So here you can see mesenchymal connective tissue. It's found all throughout the body, and it's common. It's the common source of all other connective tissue. This is mucous connective tissue. It has lots of mesenchymal cells in it. A lot of people save this, and some people even eat this after giving birth. They take their umbilical cord and and the placenta, and they basically turn it into a pill, and then they use it for nutrients, and it's supposed to be really good for them. I don't know, but it's kind of interesting. Mesenchyme then differentiates into different types of connective tissues. So you can have connective tissue proper, supporting connective tissue, or fluid connective tissue. Connective tissue proper is going to be your loose and your dense connective tissues. Your supporting connective tissues are like your bone and cartilage connective tissues, and then fluid is going to be blood and lymphatic connective tissue. So loose connective tissue contains very little cell substance and not a lot of proteins, fibers, but it does have a lot of ground substance. So it's a packing material. It's also good for helping to bind certain structures together. and it produces a structure for certain organs. The three types are areolar, adipose, and reticular. So here's areolar connective tissue. We have our different mesenchymal cells. We have our adipocytes. We have some fibroblasts in here. We have collagen fibers as well as elastic fibers found in here. It contains mixed macrophages, fixed and wandering macrophages. It's found in any area of the body where we have epithelial tissue, since it makes up the basement membrane. So it's found in the papillary layer of the dermis. The papillary layer is the initial layer of connective tissue deep to the epidermis, which is stratified squamous epithelial tissue. It's also found in the subcutaneous layer. That's another area. Adipose connective tissue has predominantly adipocytes. It's the main thing, but it does also have some, well, I guess I won't say that. It has adipocytes as well as blood vessels. It's a highly vascular connective tissue. These adipocytes can get larger if we fill them up more, or they can get smaller if we don't fill them. So it's fat basically is an insulator. It's long-term energy storage. And we find this adipose tissue surrounding a lot of our organs. So like around the kidneys, we find fat around the heart. Almost every one of our organs has some fat around it. And then we have reticular connective tissue, which has fibroblasts and a lot of reticular fibers. Also has a lot of white blood cells. It's it forms the stroma, or the framework of a lot of our lymphatic organs. And so is very important in the lymphatic system. There's your 3 loose connective tissues. Now let's look at the dense connective tissues. Dense connective tissue propers. We have dense regular, dense irregular, and elastic connective tissue. These are going to have mainly the fibers, lots and lots of protein fibers. And then along with the protein fibers, there will be some ground substance and very few cells. Here's dense regular connective tissue. We see the little fibroblasts. Here, this is the nucleus of a fibroblast in these different areas. All of these are collagen fibers. The collagen fibers run in a very organized stack. Looks kind of like a wavy ocean. That's how I like to think of it. A very happy, clear, relaxed ocean. The function, dense regular connective tissue, is pretty much avascular, so it doesn't heal well. We find dense regular connective tissue making up our tendons and ligaments, and so we get a lot of protection against specific lines of stress. But any potential damage in a different line of stress could damage the ligament or tendon. Oftentimes people get ACL damage, and when you get ACL damage, you have to have it surgically repaired, because dense regular connective tissue does not heal like other connective tissues. Dense irregular connective tissue is composed predominantly, again, of fibroblasts with tons of collagen fibers, but the collagen fibers run in multiple directions. So this gives us protection on multiple areas or lines of stress. Has a really good blood supply. We find the dense irregular connective tissue in the dermis of our skin, makes up the majority of the dermis of our skin. It surrounds our bones and our cartilage. It's a very tough and protective connective tissue. And the last is collagen, or is elastic connective tissue. Elastic connective tissue functions in stretch and recoil. So it has a lot of the collagen, or not collagen, I'm sorry, elastic fibers. Oh, hold on one second, sorry. Sorry about that. My phone just went crazy. So elastic connective tissue functions in stretch and recoil. And so we have a lot of the elastic fibers in elastic connective tissue. We find elastic connective tissue in areas where we have a lot of stretch and recoil. So our lungs, our trachea, arteries, vocal cords have elastic connective tissue associated with it. So these are the first three connective tissues, well, mesenchyme, so the first, no. These are the second three connective tissues other than the mesenchyme. That's what I want to say. I'm going to stop here, and I'll put the other connective tissues in our next video, okay? Bye.